All right, in our first example, we're going to use reference triangles to evaluate sine and cosine of different angles. So what is the sine and cosine of the angle 2 pi over 3? So let's start by drawing the angle 2 pi over 3 with our unit circle. So I'm going to draw this kind of bigger. Okay, so here we have coordinate plane. Here's our unit circle. Just a couple reminders about the unit circle. It does have a radius of 1, so you know where it hits each axis. This is a 1, that's a negative 1, this is a 1, this is a negative 1. It's always good to keep that in mind. And then we are going to evaluate the sine and cosine of the angle 2 pi over 3. So let's sketch the angle 2 pi over 3. That's a radian measure. And if you remember what we do there is we ask ourselves, what is pi being divided into? Pi is being divided into 3 sections. Remember, pi is the same thing as 180 degrees. It's this top half. I'm going to divide that into 3 sections. So here's 1 pi over 3. Here's another pi over 3. Here's another pi over 3. So 2 pi over 3 is going to be the angle. Here's the terminal side. Nope, just kidding. That's the initial side. The terminal side is 1 pi over 3, and it says we want 2 pi over 3. So we're going to go one more to 2 pi over 3. So that's the terminal side of our angle, 2 pi over 3. Okay. So when we draw an angle in the unit circle, we can plot that point right there where our angle hits, where our terminal side of our angle hits the unit circle. You will hear that called the terminal point. So that terminal point has an ordered pair. What we're going to do is we're going to create a reference triangle. Reference triangle is the triangle formed when you connect that terminal point to the x-axis. So I'm going to draw a line straight down to the x-axis, and there is our reference triangle. We do want to know the angle at the origin. That's our reference angle. So because we had pi divided into 3s, pi over 3, pi over 3, pi over 3, our reference angle is a pi over 3. And then that's one of our common radian measures. Pi over 3 is going to have the same value in degrees as 180 divided by 3. So that is a 60 degree angle. So we're going to keep in mind we are working with a 30, 60, 90 triangle. I'm going to go ahead and, well, no, I'm just going to leave it right there actually. So if you remember, in the unit circle, the hypotenuse is 1. The shortest side, or not the shortest, yeah, the shortest side. Here's our shortest side. That's across from the smallest angle. Remember, if pi over 3 is our 60, this must be our 30 degree angle. And our side opposite that shortest side is going to be half of our hypotenuse. So 1 divided by 2. And then our other leg, which will be opposite our 60 degree angle, is 1/2 the shortest side times root 3, or root 3 over 2. So because we are in a coordinate plane and we're drawing a triangle, now we know triangles have positive side lengths, but we are going to start to put signs in, positive or negative, and we're treating these side lengths as x and y values. So if we're at the origin and we go to the left 1/2 units, that would actually be a negative 1/2. And if we go up root 3 over 2, that's a positive root 3 over 2. And that's going to get us to that ordered pair. So that ordered pair is negative 1/2 root 3 over 2. So we're being asked to evaluate the sine and cosine of our 2 pi over 3 angle. So the sine of 2 pi over 3, what's really nice about our reference triangle is your reference angle will have the same trig values as the angle it's referencing. So because we found the triangle using pi over 3, I know it will have the same trig values as 2 pi over 3. I just have to pay attention to if your side lengths are positive or negative. So if we look at sine of our angle here at the origin, it's opposite over hypotenuse. The opposite side is root 3 over 2 over 1, which is just a root 3 over 2. So sine of our angle is root 3 over 2. Now cosine of 2 pi over 3 is going to be the same thing as cosine of our reference angle. Cosine is adjacent side over the hypotenuse, so the adjacent side is negative 1/2. The hypotenuse is 1, so the cosine of our angle is just a negative 1/2. Now you'll notice these are the same values as our ordered pair up here. So when you have an ordered pair, on the unit circle, so this xy has to be on the unit circle, and we saw this in our last lesson, cosine of your angle is equal to the x value, and sine of your angle will be equal to the y value. So it all kind of ties together quite nicely. Okay, so what is the sine and cosine of a negative 45-degree angle? Well, let's draw that into our unit circle again. And I hope we're seeing the usefulness of the unit circle is we get a terminal point on the unit circle. We can draw a reference triangle, and we know the hypotenuse is 1. That's why the unit circle is really helpful. Okay, so I went ahead and drew the unit circle in the coordinate plane. Just remember, this is a 1, this is a negative 1, this is a 1, this is a negative 1. That comes into play in this lesson, so it's just always to remember that. So what are the sine and cosine of a negative 45-degree angle? So we're going to draw a negative 45 degrees. Negative means it's going to go down, and it's going to go into this fourth quadrant halfway, half of that 90 degrees. So just do your best to draw a negative 45-degree angle. Okay, so what we do is we put a point on the unit circle, we create a reference triangle, we connect it to the x-axis, and then we ask ourselves what the reference angle is. Well, if we went down 45 degrees, to connect it back to the x-axis would be 45 degrees. So this is a 45-degree triangle. 45, 45, 90. What we want to remember about that is it is isosceles, so you will have two congruent sides. And again, the hypotenuse is 1. So what we don't have are the other two legs of the triangle. So we're just going to do a little bit of side work here. If we have, well, I guess we could do it two ways. If we know that the two sides are the same, let's call them both x. How about? So, and we can use Pythagorean theorem. So x squared plus x squared equals 1 squared. There's your a squared plus b squared equals c squared. Well, x squared plus x squared is two of those, so we have 2x squared equals 1. Let's divide both sides by 2 to solve for x. X squared equals 1/2. Square root both sides. So x equals, this would be positive and negative, plus or minus when we square root in an equation, but because we're dealing with triangle side lengths, we're just going to use the positive right now. Square root of 1 over square root of 2, which is 1 over root 2. But then we have to rationalize, and we get root 2 over 2. Now, that's kind of a lot of work. Do you have to do that every single time? No. You could just memorize that a 45 triangle on the unit circle has side lengths of root 2 over 2. So I'm going to put those side lengths into the triangle. This is a root 2 over 2. And because we're going to the right, that's positive. This is a root 2 over 2, but because it's going down, that is going to be a negative root 2 over 2. So that ordered pair right there is a positive root 2 over 2 for the x, a negative root 2 over 2 for the y. So because we have to evaluate the sine and cosine of our negative 45 degrees, sine of negative 45 degrees will be the same thing as sine of our reference angle 45 degrees. And we could jump right to the ordered pair. Remember, we said in the last one that your x value is cosine of your angle. Your y value is sine of your angle. So sine of negative 45 is a negative root 2 over 2. Cosine of negative 45 degrees is a positive root 2 over 2. So we want to remember those connections with terminal points on the unit circle. The x is your cosine value, the y is your sine value.